Hi there once again, and welcome to another Expresso mechanic tutorial. And this is the second and final part in my series on creating a punch card reader. Now at the end of the first tutorial, we'd created the card, we'd encoded the message within it which says Expresso mechanic, and we'd also created the scanner and completed the first step in creating the animation for making the scanner scan the card. Our focus in this tutorial will be on making the scanner actually read the card, as it would do if it were a real device. Once it's actually completed its reading, we'll make it reset itself and then start the process again. We'll also present the message encoded in the card on a computer screen. That's what we're about in this tutorial, so without further ado, let's see if we can make this happen. The first thing we need to do is work with our Expresso here, in particular this Python node. And what we need to do at the output stage is add another output, and this time it needs to be a string. You will see why a little bit later. So if we rename the port and I call it message, you'll probably get a hint as to what we're going to do. We're actually going to be outputting letters that make up the words Expresso mechanic from this port. That's what we're doing, but you'll see what happens there a little bit later, as I said. So that's our first little piece of this underway. Moving on from here, we have to correct something that I showed you in the last tutorial. I said there was a deliberate mistake within the punch card. So if we just close down the Expresso editor for a second and change our view to our front view, so F4, let's have a look and see what we've got in here. In fact, what I'll do, let's have a think. Shall we go back to a standard view to make it bigger? Yeah, why not? Let's go back to the standard view. So we've got E, X, P, and R. Now, the R here is actually reading 90 at the moment, and it should be reading, I think, 82. So it should be 64 plus 16, which is, that's 80 in itself, isn't it? And then we've got 8 here and 2, so that reads 90. We need it to read 82. So this circle here actually shouldn't be on the card. It should be removed. So if we go into the punch card and select the card, select points mode, we can select, and we'll get our selection tool and check off visible only. We don't want that on because we want both sides to be got rid of. So we can just do that. And now we're reading 82, and that's correct. So bear in mind, I left that in there to show you this. It's very easy to make a mistake when creating one of these cards. But if you do, you'll find that when you try and read it, you'll get an out of range error because obviously there's stuff in there that shouldn't be there. Okay, so that's always a good thing to look out for. Just make sure you've got your card set up correctly. Right, great. Let's go back into the script layout. Click on here, and click on here. And we're ready to start work on the Python. And from here on in, it's all code. The only thing I need to do before I create any code is to produce a text spline. We'll make it, well, it doesn't really matter what size it is because it's not going to be used as is, but we'll, just for the sake of argument, make it about 20 just to get it into a size that's sort of manageable and not sort of too intrusive. So we'll leave it at 20 and we'll leave it there. And what we need to do is pull this into the Expresso editor and then give it a port at the input stage, and it will be a text spline input port. And then the message, when the time comes, that output port can be plumbed into the text spline input there. But we'll leave that for now, that's for later. Right, great. So we're ready to move on and we're ready to do some more coding. We'll start at the top and we'll add some more global variables. For a start, let's just, if we just execute, I just want to see if anything changes. It doesn't. What I need to do, I've got to add the message output port. So I've got to say global message. That's the first thing to add. I then need some more globals, and that will be global temp. You will see what these do as time progresses, so don't worry too much about them at the moment. Global string. Global flip-flop, because we're going to be using one of those in a very short while. Global check underscore sum. And finally, global counter. And those are our global variables completely set up. We don't need to do any more. Now, in the first tutorial, I said that we would be using an aspect of Python that we'd never looked at in any other tutorial before, and that would be dictionaries. Well, now's the time that we've actually got to do that. Before we go there, if we look at binary here, this is a list, and we can see that the convention for it is that we place a list within square brackets. We place a value, or it could in fact be a letter, but we're placing values on this occasion. So we place a value, a comma, a value, a comma, etc. And that's the protocol for creating a list. Now, dictionaries are different. Our dictionary is going to be called letters. So we'll say that straight away, and it will be equals. And then instead of square brackets, we're going to use curly brackets. That's the first way that dictionaries differ from lists. The second way is in the protocol for defining them. Instead of using the convention within the list, you have to use a convention called keys and values. Now, values is a bit of a misnomer because a value suggests that it will be a number, but no, it can be a number, it can be letters, it can be a combination of letters and numbers. And the same applies to keys. So these are highly versatile for that reason. But we're actually going to be using numbers for our keys and letters for our values. The first number we're going to use is 32. We then place a colon, and following the colon, it's simply a case of typing a single quote followed by a space followed by another single quote. And that's our first key, and this is our first value. What we've got actually here is 32, which is the ASCII value, the decimal value, for a space. And that's why I've put a space between the two quotes. Moving on from here, we simply place a comma, and we can say 65, colon, inverted commas, capital A. So once again, 65, this is the decimal value for a letter A. So that's the ASCII code for a letter A. We'll move on from here, 67, colon, inverted commas, capital C. And that's our third key and value taken care of. And we can go on from here and place the rest of the characters that make up the words Expresso mechanic within our dictionary. So we know that 69, that's going to be an E. We know, well, you may not remember, but I know that 72 is an H. '73 will be an I. 77, a letter M. 78, an N. 79, an O. 80, P. 82 will be the R, as we discussed earlier. 83, of course, will be the S. And finally, 88, if you remember from the first tutorial, is X. And then we simply close our curly brackets, and we've created our dictionary with our keys and our values, which will make up the words Expresso mechanic. So that's where a dictionary is very important. It's actually the key line, really, because this is the thing that makes the whole thing hang together. So hopefully that's clear and useful to know. Moving on from here, we need to initialize our remaining variables. So we'll come into our if statement here, and we'll say checksum is equal to, and it will be an empty list. Flip-flop will be equal to 0 within our list. String will be equal to an empty list. Similarly for temp, another empty list. And finally counter will be equal to 0 within the two square brackets. And that completes the initialization of our variables. Moving on from here, I just need to add a line of code here. So I'm going to just indent there and say if flip-flop brackets 0 is equal to 0 colon, and then I can indent all of this code once. So that needs to be within another if statement. That's the first thing we have to do. The next thing we need to consider is creating the code that's going to enable the scanner to actually read the card. So this is a very, very important piece of code that's coming up next. Before we go there though, I've just realized I've made a slight mistake. Ha. I needed to say flip-flop is equal to 1, not 0. That's where it needs to be at the initial state. So that should be a 1, not a 0. Moving on from here then, we can create our code that's going to enable the scanner to read the card. So here we say if frame is greater than 0 and flip-flop bracket 0 is equal to 1. So in other words, now we've got a 1 in here, we're going to do this, this piece of code is going to be used first. I want the actual reader to read the first line before it moves. Okay, so that's what we're doing. So that's why we've set this up that way. I can then say if len checksum is less than 7, if bool is equal to 1. So a nested if statement, it's what, three-way nested if statement we've got so far. We can then say checksum dot append, and it will be binary square brackets index close square brackets, and then here else checksum brackets 0, oh sorry, I beg your pardon, checksum dot append, got ahead of myself a little bit there, brackets 0. Okay, so that's the first little bit of this done. So what are we doing here? Well, the checksum has a maximum length of 7 numbers because there are 7 numbers in combinations of 1s and 0s across the actual width of the card. So there's obviously the holes are 1s and the spaces where there are no holes are 0s, and there are 7 of them. So we want the checksum to be 7 values in length. So we check the value of the bool which is coming into the input here. And we know that this is based on what's happening in the ray collision. So if the ray collision is outputting a value of 1, that means that we've actually got a 0 in here because we're comparing this to 0, aren't we? So if a 0 comes out of here, we know that we've actually got a 1. So it's a little bit backwards, but that's the way it works. And what we're going to do, so if we're getting a 1 at the output or one of the compare, then we're going to append the checksum list with binary, so one of these values, and according to the index, which of course comes in from the iteration. It matches up with the index that's being taken from the iteration. So that will tell us which one of the actual targets in our scanner is actually producing a 1 or a 0. And based upon that, if we're going to get a 1, we find out the index value of the target that's actually passed through the hole. We grab the number from the binary list here, and we place that into the checksum, and it will match up with the hole in the card, because obviously we're going to go 1 0 1 1 0 0 0 0, and that's how we're going to do it. And you'll find that the checksum will actually read like that. Okay, so that's what's going to happen there. We'll either get a number from the binary list or a 0. So that's how that's going to be working. That's the first part that we need to make this work. Once we've achieved that and we've got our checksum all set up and it's got its 7 digits in it, we can then start to work out the actual value that we get from adding all of those numbers together. So what we're going to say then is if len checksum is equal to 7. So if it's complete and it's full up with all its figures, then we need to look at this. We then use a local value. We just simply say x is equal, or local variable I should say, x is equal to sum, and it will be checksum. So we'll get all of the 7 values within checksum, some of which are going to be taken from binary and some of which are going to be 0, and we add those numbers up. Moving on from here, we use a for loop, and we say for I, and this time it's just a different type of for loop. So we say I comma L in letters dot items, open close colon. So we're going to actually scan through letters, and we're using a double, well, it's effectively a double for loop because it's sequencing 2 values, isn't it? Well, one is the keys, the I is the keys, the L is the values. So we're looking at these and we're looking at these. So from here we can say if x is equal to I, double equals I should use for that, is equal to I, if len brackets temp is less than 1, temp dot append, and it will be L. So with our for loop, we're scanning through our letters dictionary, and the dot items is looking at both the keys and the values. And when we reach the point where x matches up with one of the keys, which of course it's got to at some point within the for loop, then basically we append temp with the value. So if I is equal to 32, we append temp with a space, etc. Okay, that's how this is going to work. So you can see what's going to happen here. So temp is going to actually be taking in a letter or a space. So at the level of our for loop here, we can then say if len string is less than 1, string dot append brackets, and it will be temp brackets 0, else string, and it will be 0 plus equals temp brackets 0. So if our string has got nothing in it, so if our string list up here, which we know starts as an empty list, if that's got nothing in it, then we simply append what's in temp. So we put the first value in there. If string has already got something in it, then we add the current value, which of course will be a letter, the current letter that the scanner has reached. We add that current letter to the string. So it enables us to build our string 1 letter at a time. That's exactly what we're doing here. Moving on from here, we can say flip-flop bracket 0 equals 0. So at this point we want to switch the flip-flop from a 1 to a 0, because we'll want to do this next after we've completed this stage. We can also clear out temp, so we can say temp.clear and set it up for its next cycle, because temp can only ever contain one letter. String contains multiple letters, or we want it to eventually, but temp must only ever contain one letter. To finish this section off, we simply need to say check_sum dot clear, open close, and that should set this code up for its next cycle. And then down at this level we can say if len string is less than 1, message is equal to, and it will be str, which is string, open brackets, single quote, space, close single quote, else message equals str string, open square brackets, 0, close square brackets. So if our string has no length, we output a space from our message here, and if it does have something in it, we output whatever it is that's in the string. So we should be able to plumb this in here now and see something change. At the moment we're not getting anything, but we should, because we're not at frame 0 at the moment. So let's just return the timeline to 0. I'll get this out of the way. If I just return the timeline, yes, straight away we do actually get something. So that means we're outputting this piece of code here. So message is equal to just a space. That's what we want. Let's just clear that out just to see if we've got any errors here. So theoretically, we should be able to run the timeline, and we should see the scanner move, and we should gradually start to see the words Expresso mechanic appear here if all goes well. So let's give this a go and see if it works. Straight away we get the E. Yes. Perfect. Look at that. It's working exactly as it should. There's Expresso space M. Yep, absolutely perfect. Yep, it all works. And there you go. So the first two pieces of code that we've got in there are now working together. The flip-flop's working, and it's alternating between our piece of code here which moves the scanner and our piece of code here which allows the scanner to read the letters that have been encoded within the card. So that's fantastic. Those two are working harmoniously together. So that's great. We can move on from here then and work on the code that's going to make the scanner actually reset itself when it reaches the bottom of the card. So where does this last piece of code actually need to go? Well, it needs to go just below this piece. And we'll start by saying if counter bracket 0 is equal to 17. So we're using counter now. So in other words, if we've literally scanned the entire card, because we know that there are 17 potential letters, I mean one is a space, but 16 letters and one space, so there are 17 characters encoded within the card. That's what we can say. So if we've scanned all of them, we can then say, and I'll copy this from here, if len start time is less than 1, this is where it starts. Start time, append frame. But things get a little bit different here. We can then say if len check_sum is greater than 0, checksum dot clear. So we're clearing that out. We can then say, and again we can copy, we can say duration is equal to frame minus start time. So that sets up our monoflop again. But on this occasion, we'll copy this here, but we are going to make a change to it. We can say if duration is less than, and this time it's going to be 150. So we're going to do this over 150 frames. And then we can copy our range mapper and make some changes. We can say range mapper is equal to c40.utils.rangemap, and it's going to be duration. It'll be 0 to 150. So we need to change that. And it will be in here minus 320 to 0. So we're counting backwards from the bottom up to the top to its 0 position. And again, false and spline, we can leave those as they are because that's absolutely fine. We can then say move. In fact, can we copy those? I think we can we? Or no, we can't. We can say move scanner is equal to range mapper. It's just purely range mapper this time, so I won't bother copying. Is equal to range mapper, and then value brackets 0 is equal to move scanner. And that code should bring our scanner back to the top once it's finished. Now, in order for that to work, the counter has obviously got to be increased. So where do we increase the counter's value? Well, we do actually have two choices. We can either do it within the first piece of code here. So at the bottom here, we could say counter plus equals 1. Or we can do it in this piece of code. Now, I prefer to do it in this piece of code because I think it works better. So I'm going to place it here. So counter 0 plus equals 1. I'm going to place that in there. So that will increase our counter, but we also need to reset our counter after we've done all of this. So after our scanner has been moved back to the top, we need to reset the counter, and we need to reset some other things as well. So we need an else in here. And we need to say else start underscore time dot clear string dot clear. So as our scanner is returning to the top, the message will remain on screen, but as the scanner reaches the top, we want the message to disappear. So we'll clear out the string at that point. We want counter to be reset here. Counter brackets 0 is equal to 0. And finally, we need to set up our flip-flop. So flip-flop is equal to, or rather flip-flop brackets 0 is equal to 1. Get that right, equal to 1. Okay, that's fine. So that's everything set up and ready for a repeat performance. So the moment of truth, really, we'll try this and see if it actually works. I need to increase the timeline though, because obviously we need some extra frames. Let's make this, we'll just go 2000 for the sake of argument. And let's see what happens when we run the timeline. So all is looking good. Well, it jumped a bit there, didn't it? So it's not quite perfect, but it goes back, and then we get an error. In fact, because I've got a syntax error in there. I've put strat time actually. That was the error there. But yeah, I mean it's almost working, but not quite, because it did do a jump here. Well, the reason for that is because we need to put an else in here. So this here is an if-else situation. What we now need to do is select all of the code and indent one level. So all of this code has got to be in this else condition. Okay, so let's give this another go. We'll just click in here and just give this another go and see what happens. And again, everything is working okay so far. So that's what we need to see. This time it works. That's okay. Yeah, that's reset. And we seem to be okay, don't we? Everything looks as if it's doing what it should be doing. Let's just make doubly sure. We'll let this reset itself. Up we go. And yeah, that's working exactly as it needs to work. So there you go. That's how you do this bit of it. So we've got all of this set up and it's all working as it should. The final step for us then is to bring in some more elements of the model here, including the computer, and then we'll place the message on the computer screen. And that will be the last thing we need to do. And by the power of editing, we have the remaining elements in the scene. Now, you can see that these are really simple objects. None of them are particularly complex. With regard to the scanner, I've enhanced it because obviously I wanted it to slide down this post. And all I did, I brought in a tube. I gave it 9 rotation segments because that gave me a segment facing directly towards my scanner head here. And all I did then was just made the tube editable, selected both objects, connected them and deleted so that they were one object. And then all I've done is selected just a single polygon on the back face of this part and a single polygon on the tube. And I just used the bridge tool to actually join them together. Dropped them into a subdivision surface, and I also put a bevel on them as well. Bevel, I just used a 1 centimetre offset and 3 subdivisions. That's all I did in there. So I've kept it pretty simple, and the same applies all the way through really. If we come down to the base and we look at that, that started life as a cylinder, and I gave this one, I think, 8 rotation segments. And then all I did, 2 height segments, made the thing editable, moved the second row of, or the middle row as it would have been, the middle row of edges, I just moved those down close to the bottom, and then switched to polygon mode and extruded this outer ring here of polygons and just brought them out to create the basic shape. And then in here I just used an inset and then extruded downwards into the thing. That's all I did. And then the post is just a simple cylinder. Mine is 12 centimeters in radius, 360 in height, 1 height segment and 16 rotation segments. That's all I've done there. On the caps I've just filleted the thing. That's all I've done. A small fillet on there, just 1 centimeter radius with 3 segments. And then finally, you saw that I'd left a little bit extra on the bottom of the card, and that was so that it could fit in this holder. And all this was just a cube made editable and then manipulated to the correct size. And then along its z-axis, I believe I gave it 5 segments. Yes, 5 segments. And then again, I just manipulated the edges until they were in the correct sort of place, and then extruded 2 polygons to create the actual final product. That's all I've done there, and then drop that into a subdivision surface and put a bevel on it. That's as much as I've really done there with any of that. You know, it's none of it is complex. There's just nothing about any of this that's complex. There's the card support in there. In fact, it's a cube. Yeah, there's a bevel on it. I didn't even put it into a subdivision surface. I just put a bevel on it. So that's all I've done with that. And then the computer, that's even more ridiculously simple, really. It's just a cube. I haven't even modeled the thing. All I've done is put this monitor on top of it here, and all I've done with that is just created a tube. And I've manipulated it again into the correct shape. Let's see what that is. So we've got it here. Where's the tube for the screen? It's that one. So outer radius, it's what, 92, forget the decimal point numbers, by 78, 60 rotation segments, 1 cap segment, a height of 162. And then that's as much as I've really done there. I've filleted it. Again, it's 2 really, forget the numbers after the decimal point, and then 3 segments. That's all you really need to do there. And the screen itself, that's just it would be a simple cylinder, once again brought out to the correct size so that it just fits with inside the other tube, and then made editable because I needed to create a selection to display the text on one face. So what I did there in the selections, I just said store selection with all of the polygons that make up the screen selected. That's all I did there to create that store selection. And then that, of course, is used to make this material actually adhere to the screen. That's all I've done there. It's here. So it just uses that to adhere the texture, this texture here, to the screen. That's all I've done. You can see I've got the selection there. And then in the material, this is probably the most important part. All I've done in here, 2 channels selected, the color and the luminance, and they're both identical. They've got the text spline in them, and in the text spline I've made the actual font Subway ticker, which is one that I happen to have. You can use any font you like. It doesn't really matter where it's aligned to, but it's left. And actually, I suppose it does, because we want the text to write on from the left to right. So yeah, left align it. Leave that like that. And the height is just 40. So that's all I've done there. Nothing special with it really. And then in here, I've said line texture, I wanted color. The same with fill texture, and they're both green. The offsets, so the X offset, I've got 2%, the Y 50%, and the X and Y scales 18% and 19% respectively. Single pixel for the line width, and the caps are on, the fill is on, and the use fill color. So they're all there just to give us solid text. Obviously there's a cable here. Well, that's just a circle which has been swept along a spline. That's all there is obviously there. And then a couple of smaller tubes placed here and here for the cable to plug into at each end. And that's as much as I've really done there. That's all you need to do in order to make this work. Okay, and if we run the timeline now, you'll see the text magically appear on the screen. We can see it's writing on with the text spline, so we can make that invisible. And now that's fine, and it works perfectly. And as before, when the scanner returns, the screen still has the message on it. Then it disappears when it gets to the top and starts again. And that's it. That really is how you go about making this. So quite involved in terms of the Python. The Expresso, not too much really. Not too much Expresso at all, if we have a look at that. So there's the whole expression. So not, as I say, not a great deal of nodes, an iteration, a couple of linked lists, ray collision, which is one of the all-important ones, a compare, and then everything else just feeding in to the Python node, which is the brains of the thing. It's kind of like the CPU. And it almost looks like one, doesn't it, with the legs coming out here, there and everywhere. It does have that sort of CPU type look about it in a way. If we just open this up in the editor here, we can see that there are sort of a number of different stages to it. So we've got our globals up here, followed by a list for our binary numbers and a dictionary, which we're using for our letters. So we've got those two in there. We've got the spline for the spline data that we use within the range mapper. That's in there. At frame 0, we just initialize the various variables that we need to use throughout the rest of the code. And then we start up here with the code that returns the scanner to the top of the post after it's checked the card and done a full scan of the card. And if we're not doing that, then we've got to do one or the other of these two things. So we're either moving the scanner or we're reading the card. So there's 3 definite states here, which we've covered using 3 separate blocks of code. That's what we've done here. And that really is all there is to it. It looks more complicated than perhaps it is, as code often does, I guess. But it's really actually quite straightforward what we're doing here. But anyway, that about wraps this tutorial up. So I really hope you've enjoyed this short series. I've really enjoyed bringing it to you. So as always, I hope that you've really got something out of this and that you've learnt some new techniques that you can perhaps have a go at applying to some of your own projects. And if you have, then please give the video a like. And if you haven't already, please subscribe to the channel. Leave a comment and of course ring the bell. And wherever you happen to be on social media, then please, as I always say, please share this video, because all of this good stuff really does help the channel keep on moving in the right direction. But anyway, that wraps this series up, so I'll see you very soon on the next tutorial.